Long before the first stars ever shone, before galaxies spiraled and clusters collided, there was silence, a cosmic calm filled only with potential. The universe, then just a few 100,000 years old, was still in its infancy, vast, expanding, and cooling. It was a sea of darkness, made of hydrogen, helium, and the faint whisper of radiation left from the Big Bang. There were no galaxies, no light, no structure, only a uniform mist, so smooth and even that at first glance, it might have seemed eternal. And yet, within that near-perfect stillness, small imperfections existed. Slight ripples in density, tiny wrinkles in the cosmic fabric. Those minute fluctuations would become the seeds of everything. In that delicate imbalance lay the story of creation. Gravity, the quiet architect of the cosmos, began its patient work. Where matter was just a little denser, it pulled in more of itself. Over millions of years, those invisible clumps grew heavier, tugging nearby gas and dark matter inward. These were the first gravitational wells, the earliest blueprints of galaxies. And though there were no stars yet to illuminate them, the universe was already alive with motion, an invisible dance of collapse and gathering, the slow awakening of structure in a sea of darkness. To understand how galaxies came to be, we must first understand that they were not inevitable. Their birth was a balance of competing forces: gravity, pressure, radiation, and time. Gravity sought to pull matter together, to sculpt order from chaos. But the young universe was hot, and its gases resisted collapse. It took hundreds of millions of years before the universe cooled enough for hydrogen and helium to gather into dense pockets. Only then could gravity begin to win. In those first moments of galactic assembly, dark matter played the leading role. Though invisible, it made up most of the mass of the universe. It did not emit light nor absorb it, but its gravity shaped everything we now see. Dark matter formed immense halos, vast, invisible spheres where normal matter could gather. Within these halos, gas cooled, condensed, and eventually ignited the first stars. The quiet birth of galaxies began not with explosions, but with gravity's silent persistence. And yet, the earliest galaxies were nothing like the majestic spirals or giant ellipticals we see today. They were small, chaotic, and raw, flickering islands of starlight adrift in a cosmic sea. These were the proto-galaxies, fragments that would merge and collide over billions of years to form larger systems. In those collisions lay the blueprint for cosmic evolution. Galaxies grew by merging, consuming one another, reshaping themselves in an endless cycle of creation and destruction. Every great spiral and elliptical we see today is the result of countless such unions, stretching back to the dawn of time. As the first stars formed, they began to transform their surroundings. Their light pierced the darkness, breaking apart the cold hydrogen fog that filled the universe. This era, known as reionization, marked a turning point. For the first time, the universe became transparent, and light could travel freely across vast distances. With it came the first traces of color, of complexity. The cosmos was no longer dark and uniform. It had texture, contrast, and rhythm. But with light came violence. The first stars were enormous, hundreds of times more massive than the sun. They burned fiercely and lived briefly, exploding as supernovae that blasted heavy elements into space. These cataclysms enriched the surrounding gas, sowing the ingredients for future generations of stars. Iron, carbon, oxygen, the very elements that make up planets and life, were forged in those early furnaces. Every atom in our bodies was once part of that cosmic cycle, born in the heart of an ancient star and scattered across the void. It is easy to imagine galaxies as serene, slowly rotating systems of stars, but their beginnings were anything but peaceful. The early universe was turbulent, filled with collisions and chaos. Galaxies collided, tore each other apart, and reassembled. Each merger reshaped them. Small irregular clumps merging into larger structures, spirals forming from the swirl of tidal forces, and massive ellipticals emerging from violent head-on collisions. Over billions of years, structure emerged from chaos, beauty from destruction, and still, gravity continued its quiet work. It drew galaxies together into groups and clusters, connected by filaments of dark matter that spanned the universe like a cosmic web. Where those filaments intersected, galaxies formed and flourished. Between them stretched vast voids, empty spaces where few stars ever shone. The pattern of a universe, this grand tapestry of light and darkness, was written in those first fluctuations from the dawn of time. As our understanding deepened, we began to see that galaxies were not isolated islands, but participants in a cosmic ecosystem. Gas flowed into them from the intergalactic medium, fueling star formation, while energy and matter flowed out through supernovae and black holes. Each galaxy was both a product and a producer of cosmic evolution, shaping the universe as much as it was shaped by it. The stars we see are not just points of light, but milestones in an ongoing process of transformation. At the heart of nearly every massive galaxy lies a black hole, a gravitational engine millions or even billions of times the mass of the sun. These black holes, though invisible, play a crucial role in galactic evolution. When matter falls into them, it releases tremendous energy, sometimes outshining the entire galaxy. These outbursts, known as active galactic nuclei, can regulate the growth of galaxies, preventing them from forming too many stars too quickly. It is a delicate balance. Too little energy, and galaxies collapse under their own weight. Too much, and they are stripped bare of the gas they need to form new stars. This dance between creation and regulation is what defines the quiet birth of galaxies. It is not a single event, but an ongoing dialogue between matter, gravity, and light. Each galaxy carries a memory of its formation. The scars of collisions, the signatures of starbursts, the quiet hum of dark matter that holds it together. To look at a galaxy is to see time itself, frozen in motion. Every star a chapter in a story billions of years long. And that story is not static. Even now, galaxies continue to evolve. Some are still forming stars at furious rates, while others have grown old and quiet. The Milky Way, our home, is no exception. It has devoured smaller galaxies, been shaped by collisions, and will one day merge with its nearest neighbor, Andromeda. In that future collision, billions of years from now, a new galaxy will be born from their union, continuing the cycle that began in the silence after the Big Bang. The universe, it seems, never stops creating. From the smallest dwarf galaxies to the largest clusters, every structure we see is part of a grand continuum, a chain of cause and effect stretching across cosmic time. The galaxies that now glitter in the night sky are the descendant of ancient whispers in the fabric of space-time, grown vast through patience and gravity's quiet hand. To understand the birth of galaxies, then, is to understand the rhythm of the cosmos itself. Slow, deliberate, and eternal, it is a story of gravity sculpting chaos into order, of darkness giving rise to light, of silence transforming into the music of the stars. And though we can now trace this story with equations and telescopes, the wonder of it remains untouched, a reminder that every star, every planet, every atom began as a ripple in the quiet beginning of time. If we could watch the universe unfold in time-lapse, we would see it breathing, expanding, cooling, and evolving as galaxies bloom like slow-motion fireworks across the dark. The early cosmos was not an even field of light, but a patchwork of birthplaces, regions where gravity was a little stronger, where gas collected into clouds, and where those first galaxies took root. They grew like coral reefs in a boundless ocean, feeding on their surroundings, building from the inside out. And even in this silent expanse, the pattern of growth had a rhythm, an unseen order governed by the laws of physics that have never changed. In those earliest ages, galaxies were restless. They spun faster, burned brighter, and collided more often than they do today. The light from their stars had to travel billions of years to reach us, which means that when we peer through telescopes at the faintest galaxies, we are looking not at the present but into the deep past, to a time when the universe was still learning how to make stars. These ancient galaxies are tiny, compact, and brimming with energy. They are the fossils of creation, the fingerprints of cosmic youth. But not all galaxies formed alike. Some grew quickly, drawing gas from vast cosmic filaments that fed them like rivers. Others struggled, starved by their environment or torn apart by neighboring giants. The universe was, and still is, hierarchical. Small galaxies formed first, then merged to create larger ones. Every collision changed their shape, their brightness, their very identity. Spirals became ellipticals. Starburst galaxies flared and faded. Each encounter wrote a new chapter in the history of the cosmos. As galaxies matured, they began to self-regulate. The same processes that gave them life also kept them from overgrowing. When too many stars form too quickly, the heat and radiation they release push gas away, slowing further star formation. Supernova explosions blasted out heavy elements, enriching the surrounding space, but also clearing regions of fuel. Meanwhile, supermassive black holes at galactic centers acted as cosmic governors, their immense energy output balancing the inflow of gas. This feedback cycle ensured that galaxies evolved in harmony with their environments. It was a self-sustaining system, a balance between birth and restraint. The deeper astronomers looked into space, the more they realized that galaxies were not simply random clusters of stars, but dynamic systems with structure and purpose. Some spun gracefully, forming thin, luminous disks like the Milky Way. Others puffed up into massive ellipsoids, dense with old stars and little gas. The difference between them lay not just in shape, but in history. Spiral galaxies were nurturers, quietly forming stars over billions of years. Ellipticals were survivors, the product of ancient collisions that had burned out their youthful vigor. The universe, in a sense, was filled with both dreamers and veterans, each carrying the scars of their past. Within the spiral arms of younger galaxies, clouds of cold hydrogen gas began to collapse under their own weight. These were the nurseries of stars, immense regions where gravity and turbulence wove the fabric of creation. Inside these clouds, new suns were born, igniting nuclear fires that would burn for billions of years. Around them, disks of dust and gas swirled, forming planets, moons, and asteroids. Every star carried with it a retinue of worlds, each one a possible stage for life. The story of galaxies is, therefore, not just a story of stars. It is a story of every world that could ever exist. And yet, for all the galaxies that flourish, many never reach maturity. Some are stunted by their neighbors, stripped of gas by powerful winds from nearby giants. Others are consumed entirely, their stars scatter like ashes into the halos of larger systems. This cosmic cannibalism continues even now. Our own galaxy is in the process of devouring several smaller companions. The Sagittarius dwarf, the Magellanic Clouds, and others too faint to see with the naked eye. Their stars are stretched into long streams, wrapping around the Milky Way like ghostly ribbons. In time, they will become part of us. The slow violence of galactic evolution is both beautiful and humbling. It reminds us that even in the grandest scales of existence, growth comes from struggle. Galaxies merge and shatter. Stars explode and die. Yet out of that destruction comes renewal. New stars, new elements, new possibilities. It is a cycle that mirrors life itself, only played out across billions of years and billions of light years. As astronomers mapped the sky and built telescopes capable of peering ever deeper, they discovered that galaxies are not scattered randomly through space. Instead, they form a web-like pattern, an immense network of filaments and nodes stretching across the cosmos. Where these filaments intersect, galaxies cluster together in great cities of light, superclusters that span hundreds of millions of light years. Between them lie enormous voids, regions so empty that a single galaxy might drift for tens of millions of light years before finding another. This cosmic web is the skeleton of the universe, the structure upon which everything else hangs. The discovery of this vast network changed the way we think about the universe. It revealed that galaxies are not isolated accidents, but the inevitable outcome of gravity acting on dark matter and gas over cosmic time. The web itself was formed by the same primordial ripples that once stirred the infant cosmos. Over billions of years, those ripples grew into filaments, drawing matter into their nodes, the birthplaces of galaxies. In this sense, the universe is not chaotic but patterned, shaped by invisible forces that have guided its evolution from beginning. Every galaxy, no matter how bright or faint, sits within one of these dark matter halos. These halos are immense, extending far beyond the visible edge of the galaxy itself. Though we cannot see them, their presence is undeniable. They bend light from distant objects, distort the paths of stars, and govern how galaxies move within clusters. Without them, the universe as we know it could not exist. The luminous matter, the stars, the gas, the dust, makes up only a tiny fraction of what is truly there. The rest is hidden, silent, and unseen. But even as we map this hidden structure, there remains a deeper mystery. Why do galaxies form at all? Why do some regions of space burst with activity, while others remain empty and dark? The answers lie partly in chance, the random distribution of matter after the Big Bang, and partly in the subtle interplay between gravity, cooling, and feedback. But perhaps the greatest mystery is philosophical. For all our understanding, the process still feels miraculous, that from a uniform fog of hydrogen, entire galaxies could arise, filled with stars and worlds and the raw materials for consciousness itself. As time flowed onward, galaxies aged, star formation slowed. The gas that once fueled their brilliance was consumed or expelled. The universe, once ablaze with light, began to dim. This gradual fading is not a sudden end, but a slow exhalation. The most massive stars have long since burned out, leaving behind white dwarfs, neutron stars, and black holes, remnants of a more active past. The cosmos grows quieter with age, its great engines winding down. Yet even now, in the deep recesses of space, new galaxies continue to flicker into being, small and faint but vital. Proof that creation has not ceased. In their silence, galaxies hold a memory of time itself. Every photon that reaches us from a distant galaxy carries a message billions of years old. To study them is to look backward through the history of the universe, to witness the transformation of chaos into order, of darkness into light. The quiet birth of galaxies is not just a scientific event. It is the universe remembering how to create. The deeper we gaze into the universe, the further back in time we look. Every photon that reaches our eyes or instruments has traveled across unimaginable distances, carrying the memory of an ancient moment. To see the earliest galaxies is to witness the cosmos in its childhood, when the rules of structure were still being written and the light of the first stars was only beginning to pierce the darkness. These ancient galaxies are faint, barely visible even to our most powerful telescopes, yet within their dim glow lies the origin of everything we now recognize as cosmic order. In those early epochs, galaxies were restless things, raw, compact, and burning with ferocity. They formed stars at astonishing rates, consuming their reservoirs of gas in furious bursts of creation. But this intensity came at a cost. Many of these young systems burned themselves out within a few 100 million years, their brilliant light fading as quickly as it appeared. Others survived, merging and merging again, growing larger and more stable. The process was slow, violent, and profoundly creative. The universe was sculpting itself through collisions, guided by the patient hand of gravity. Each merger rewrote a galaxy's identity. Two spiral galaxies colliding might become an elliptical, a dense, smooth system where the ordered motion of stars gives way to random orbits. Over time, these galaxies would lose their gas, their star formation would cease, and they would age into quiet, red giants of the cosmic landscape. Meanwhile, the more isolated galaxies, those that avoided catastrophic collisions, continued to form stars in their calm spiral arms, maintaining their graceful symmetry over billions of years. This diversity, from chaotic dwarfs to majestic spirals to massive ellipticals, is the universe's record of every choice, every accident, every consequence of gravity's design. Yet even the largest galaxies are not closed systems. They exist within a vast and interactive environment, a cosmic ecosystem that connects them through invisible flows of matter and energy. Around every galaxy lies a halo of hot, diffuse gas, extending far beyond the visible edge. This halo serves as both a boundary and a bridge, linking galaxies to the intergalactic medium, the thin, nearly invisible gas that fills the space between them. Streams of this material constantly flow inward and outward, feeding galaxies while also carry away the products of their internal processes. Through these exchanges, galaxies grow, evolve, and communicate with their surroundings. At the same time, supermassive black holes at the centers of galaxies exert a subtle but profound influence. Though they are points of infinite density, their presence regulates the life of entire systems. When matter falls into these black holes, it releases a staggering amount of energy in the form of radiation and jets. These outbursts can heat surrounding gas, drive winds that sweep across thousands of light years, and even shut down star formation by expelling the fuel galaxies need to create new stars. But this feedback also prevents galaxies from collapsing under their own gravity, a delicate cosmic balance between creation and restraint, violence and preservation. Through billions of years, this balance has shaped the universe we see today. The rate of star formation has declined. Galaxies have grown more massive but less active. The once fiery cosmos has matured into something more stable, more structured, and perhaps more introspective. If we think of the early universe as a wild, energetic youth, then the present-day cosmos is its adulthood. Calmer, wiser, still beautiful, but no longer chaotic. The galaxies that now shimmer across the night sky are the survivors of that long journey. Each one a quiet echo of an age when the universe was ablaze with light. And yet, even now, galaxies continue to change. They drift within clusters, pulled by the gravity of their neighbors. Some are torn apart by tidal forces, their stars scattered into long arcs that stretch through intergalactic space. Others are drawn inward, merging into larger systems that reshape entire regions of the sky. These events unfold slowly, over millions or even billions of years, but when viewed as part of the cosmic whole, they form an ongoing choreography of creation. Nothing in the universe stands still. Even the most serene galaxies are part of an endless, unfolding dance. When we map the sky, we find that galaxies trace a pattern too vast to fully comprehend. They form threads and knots of light, immense filaments connecting clusters across hundreds of millions of light years. This is the cosmic web, a structure woven by dark matter and illuminated by galaxies. It is both the skeleton and the bloodstream of the universe, a network that channels gas, dust, and energy through its filaments, nurturing galaxies at its intersections. It is in these crossroads where matter converges that the richest and most massive galaxies are born. The cosmic web is more than a pattern. It is a story written in the language of gravity. Its structure reveals that the universe is not a random scattering of light, but a coherent whole. Each filament, each cluster, each void plays a role in the grand design. The universe expands, but internal geometry retains memory, the faint imprint of the earliest fluctuations, amplified over time into the architecture we now observe. When we look at that structure, we are looking at history itself. The fossilized ripples of the Big Bang, stretched across the canvas of space. As we trace the lineage of galaxies through time, we begin to see how their stories connect. The gas clouds that once condensed to form the first galaxies now flow into new generations of stars. The heavy elements forged in ancient supernovae have been recycled countless times, shaping the chemistry of new worlds. Every atom of oxygen in our lungs, every trace of iron in our blood, every molecule of carbon in our bodies once belonged to stars that lived and died billions of years ago. Galaxies are not distant things. They are our ancestors. This realization changes how we see ourselves. We are not separate from the universe's story, but participants in it. The same physical laws that guide the formation of galaxies govern the beating of our hearts and the burning of our sun. The patterns of gravity that sculpted the cosmic web also shape the orbits of planets and the tides of oceans. To study galaxies is to study the reflection of our own origins, the quiet unfolding of order from chaos, of light from darkness. And though we can describe the process in equations and simulations, something about it remains deeply mysterious. For even now, as our instruments grow more powerful, there are limits to what we can see. Beyond a certain distance, the light from galaxies is stretched so far by the expansion of space that it fades into darkness. Beyond that horizon lies a part of the universe we will never observe, a realm of galaxies whose light will never reach us, forever receding faster than we can chase it. They exist, but they are lost to time. That boundary reminds us that our understanding, no matter how vast, will always be incomplete. The universe keeps its secrets not through deception, but through distance, through the simple geometry of space and time. The quiet birth of galaxies is not just a story of what we know, but also what we can never fully grasp. It is an invitation to wonder, to look upward and remember that even in silence, creation continues. The story of galaxies is a story of time itself, vast, patient, and unending. Even as we peer deeper into the universe with our most advanced telescopes, we are only catching a glimpse of a process that began billions of years ago and will continue long after our world has faded into stardust. Every image of a distant galaxy is a photograph of the past, frozen light that has traveled across cosmic oceans to reach us. In studying them, we are not just observing space, We are watching time unfold in slow motion. The galaxies we see today are survivors. They have endured collisions, mergers, and long epochs of quiet isolation. Some shine brightly, still birthing stars from reservoirs of cool gas. Others have grown old and red, their fuel exhausted, their light fading as they drift into cosmic retirement. Together, they form the grand mosaic of the universe's evolution, a portrait of change written in starlight. But even as the present cosmos seems calm, it is never still. Beneath its quiet surface, galaxies continue their slow transformations, shaped by forces both visible and unseen. Our own galaxy, the Milky Way, is part of this ongoing story. It is a vast spiral, with arms curling gracefully around a dense central bulge, home to hundreds of billions of stars. It orbits within an invisible halo of dark matter, its unseen companion and stabilizing force. Around its edges, small satellite galaxies orbit like companions. Faint, irregular shapes tugged by gravity's patient pull. Some are being torn apart as we speak, their stars forming faint streams that wrap around the Milky Way like wisps of smoke. In the cosmic future, these remnants will be fully absorbed, their stars becoming part of our own. But the Milky Way itself is destined for transformation. In about 4 billion years, it will collide with its nearest large neighbor, the Andromeda Galaxy. The two will merge in a slow, magnificent ballet that will last another few billion years. Though the word collision sounds catastrophic, the vast emptiness between stars means that few, if any, will actually collide. Instead, gravity will reshape both galaxies, flinging stars into new orbits, distorting their spirals, and eventually fusing them into a single, enormous elliptical galaxy. This new system, sometimes imagined as Mokometa, will be a fresh chapter in the cosmic story, a new structure born from the merging of two ancient ones. Events like this are not rare. They are the heartbeat of the universe, the way galaxies grow, change, and renew themselves. Through these vast unions, material is recycled, black holes merge, and new waves of star formation are triggered. Each merger is both an ending and a beginning, a reminder that creation and destruction are never separate but intertwined. The beauty of the cosmos lies in that continuity. Nothing truly ends. It only transforms. Over time, the universe will continue to expand. The spaces between galaxies will stretch wider, and distant systems will drift beyond our reach. Already, most galaxies are receding from us, their light stretched by the expansion of space into longer, redder wavelengths. Eventually, only the galaxies bound to our local group, those held close by gravity, will remain visible. The rest will fade into darkness, moving so far away that their light will never reach us again. The cosmos will grow lonelier, quieter, as its great tapestry of galaxies thins into the night. But this fading is not a tragedy. It is a natural rhythm of a universe that has always been in motion. The same physics that gave rise to galaxies also ensures their eventual stillness. As stars burn out and gas reserves are exhausted, galaxies will dim. Their remaining stars will cool into embers, white dwarfs, neutron stars, and black holes, until even those fade. In the far future, long after the last supernova has erupted, the universe will enter an age of quiet light. The faint glow of cooling remnants scattered across infinite darkness. And still, in that silence, the legacy of the galaxies will endure. Their structures written into the very shape of space-time, their influence etched into the cosmic web. When we contemplate this vast arc of time, from the first faint ripples after the Big Bang to the distant twilight of the last galaxies, it can feel overwhelming. Our lives are impossibly brief by comparison. Yet within that scale lies a profound comfort. The same universe that gave rise to galaxies also gave rise to us. The atoms in our bodies were forged in ancient stars. The oxygen we breathe was born in stellar winds. The iron in our blood was cast into space by long-dead suns. In a very real sense, we are part of the galaxy's story, living fragments of their evolution, conscious matter reflecting on its own origins. That is perhaps the most extraordinary truth of all. The universe, through its quiet, patient unfolding, has created beings capable of understanding it. From the chaos of the early cosmos emerged order. From the cooling of hydrogen came stars. From the merging of galaxies came planets. And from those planets, Eventually came minds. Minds that look upward, that wonder, that trace the faint light of ancient galaxies across the sky and ask, how did it all begin? It is as though the universe, having spent billions of years building itself, finally became aware through us. And what we see when we look out, the deep fields filled with faint galaxies, the spirals and ellipticals and irregular forms scattered like jewels across the dark, is not just a record of the past. It is a mirror. In every distant galaxy, we see a reflection of our own beginnings, of the forces that shaped us, of the cycles of birth and death that define all existence. The quiet birth of galaxies is the quiet birth of everything, stars, worlds, life, and thought itself. Even now, new galaxies are being born in the farthest reaches of space, their light just beginning its journey toward us. Billions of years from now, their glow will reach some other observer, perhaps in a world that does not yet exist. They will look up at their own night sky and wonder, as we do now, about the origins of it all. And in that moment, the story will continue. The story of the universe becoming aware of itself, one spark of consciousness at a time. The birth of galaxies was never loud. It was not a single explosion or a flash of sudden creation. It was slow, patient, and magnificent. A quiet blooming of order from the void. From that silence came everything. Stars and planets, oceans and life, questions and wonder. The same calm that once filled the newborn universe still echoes through every atom, every heartbeat, every thought that reaches toward the infinite. And in that quiet, we can still hear it. The faint whisper of gravity, the first note in the endless music of creation.